Alright, in this video we are going to practice using Cavalieri's principle to find the volume of cones and cylinders and prisms and pyramids even when they're leaning off to one side. Cavalieri's principle basically says that for a prism or a cylinder, even if you slant it and push it off to the side to where it leans off to one side, as long as the cross section, or you could think about the area of the base being the same for both, and the height is going to be the same for both, as long as that's true, then the volume will remain the same. And we're using these CDs to indicate and help you visualize, because of course if you think about the volume of the vertical prism, it's going to be the sum of all the volumes of the CD cases. And then if you look at the oblique prism, the one that's leaning, it's still made up of the same stack of CDs, it's just pushed over to the side. But if you think about it, you're still adding the volumes of each one of these CDs, so it's really going to add up to be the same volume. Alright, so in short, Cavalieri's principle says if the cross-sectional area, and in this case that's the same as the base, alright, so if the area of the base is the same and the height's the same, it doesn't matter whether it's vertical or leaning to one side, the volume will still be the same. And for our purposes, it means that when we get to problems like number 2 and you see that the cylinder is leaning off to one side, it doesn't matter. We'll still use the same formula, which is area of the base times the height. So we can, even though the height is leaning off to one side, the same formula will still apply. Remember, the formula for the volume of a prism or a cylinder is volume equals area of the base times the height. Right? That works for either one. And the formula for the volume of a pyramid or a cone is 1/3 area of the base times the height. So the formulas are the same except for the 1/3. So to help you remember which one is which, you can think of a cylinder and a cone as sort of going together. They both have a circular base. But think of a cylinder. Imagine that you took the top circle and you shrank it, and you made the top circle smaller and smaller and smaller until it became a single point. Then it would become a cone. So obviously if you took a cylinder of a certain size and you shrank the top of it, you crushed it and you squeezed it down, obviously it's getting smaller. So clearly the cone version is going to be smaller, so that's why it's got the 1/3. It's 1/3 of the volume that it was before you squeezed the top of it down. And same thing with a pyramid. You can think of a prism. If you squeeze the top of it down, it would become a pyramid. Obviously, whoops, these bases aren't the same, but you still get the idea. So the pyramid and the cone are the smaller versions of these, because you could get them by starting here and shrinking the top, so obviously it'll be smaller, thus the 1/3. So problem number 1, the formula for the volume of a prism like this is area of the base times the height. So we need the area of the base. The base is nicely shaded for us. So the area of this base, which is a triangle, is 1/2 the base of the triangle times the height of the triangle. So don't get the base of the triangle, which is 12, confused with the area of the base of the whole prism. So we're using this word base in two different contexts. Alright, this capital B from the volume is the entire area of this triangle. But this lowercase b is just the 12. Alright, and the height of the triangle is 5. but that is not the height of the prism. The height of the prism, this h, is the distance between the two bases. So this 10 over here is actually going to be the height of the prism. Okay, because it's the distance between the two bases. Alright, so anyway, the area of this base, the triangle, is 1/2 base times height. So that's 1/2 12 times 5. 12 times 5 is 60. Half of that is 30. Okay, so that gives us the volume is area of the base times the height. So that's 30. And then the height is 10. And of course 30 times 10 is 300. Alright, and volume has cubic units, so 300 cubic centimeters. Alright, so again, here we have this cylinder, an oblique cylinder. The formula for the volume will be the area of the base times the height. The height is given. Notice the height is not this slanted length. It's the vertical distance between the two bases. And that's 5, so we might as well go ahead and fill that in. Now we need the area of the base. Well, the base is a circle, so off to the side, let's go ahead and calculate the area of the base. Okay, so the area of a circle is pi r squared. So that's going to give us pi times 2 squared, which is 4 pi. So that's the area of the base. Okay, so that is going to give us 20 pi. And of course volume is cubic inches. But let's also give the volume as a decimal. Right, so 20 pi, got to toggle it for the decimal, so that's 62.83. Alright, so that would be 62.83 cubic inches. So for number 3 we have a cone. And of course the volume of a cone is 1/3 the area of the base times the height. So that's 1/3. We're going to need the area of the base and the height. We're given the height, it's right here, it's 12, so we can go ahead and put that in. So all we need is the area of the base. Now the base, of course, is this circle right here. So off to the side, let's go ahead and calculate the area of the base. Well, because the base is a circle, we should be thinking pi r squared. Alright, the radius is this 8.6, so that's pi times 8.6 squared. Alright, so that's pi 8.6 squared. Okay, that's this number right here. Now what I might do, because I don't like to round until I'm finished, so let's just do the 8.6 squared separately for a moment. Okay, so that's 73.96. Alright, so that would make this 73.96 pi. Now I would never leave my final answer like this, but it's convenient for now. So 73.96 pi. That way we haven't lost any accuracy yet. We didn't round anything. It's perfect. So now we can go ahead and find the volume from here. So if I can remember this. So this is going to be 1/3 whoops. And then we had 73.96 pi, so 73.96 pi. That was the area of the base. And I think the height was 12. Yep. Okay, so here's our final answer, and now it's okay to round. So 929.41 got to round up. And we had inches for the length, so it will be cubic inches for the volume. Alright, for number 4 we have ourselves a prism. The formula for the volume of a prism is the area of the base times the height. Of course, you could just think of it as, length times width times height, and that's fine also, but notice it also works to think of it as the area of the base, and because the base is this rectangle right here. Okay, see if I can make that any clearer. Yeah, so the base is that rectangle right there. So that's your 9 times 7. So you could think of it this way, that the volume is equal to, so 9 times 7 is 63, so that's the area of the base, and then times the height, which is 3. Now, of course, that's the same thing as doing 9 times 7 times 3. Anyway, 63 times 3 is 189. So either way, we get that the volume is 189 cubic inches. For number 5, we have another prism. So again, the volume is going to be the area of the base times the height. Alright, so we'll need those two. The height is this the 3.2 feet. So we've got that. Might as well go ahead and put it down. So all we need is the area of the base. So please understand that this is the base down here, this rectangle. The area of a rectangle like this is just going to be base times height, length times width, so 2.5 times 3.5. So that's 8.75. Okay, so 8.75 times 3.2. So I've already got the 8.75, so I can just go times 3.2. So that's exactly 28. So my volume is 28, and the length was feet, so the volume will be cubic feet. Number 6 is a pyramid. So the volume of a pyramid is 1/3 the area of the base times the height. Okay, so that's 1/3 area of the base times the height. Now, let's see, so the height of the pyramid is this over here, which I'll put the H over here. This is the height. And we aren't given it, so we're going to have to calculate it somehow. Alright, I feel a Pythagorean theorem coming on. So we've got all these numbers, but if I want to find this height right here, I need to focus my eyes on this sort of light blue triangle. Let me highlight it. Okay, so to find the height of the pyramid, we'll need to find this side of the triangle. So we'll do our Pythagorean theorem on the yellow triangle. So that'll be h squared plus 15 squared. And of course, h stands for the height of the pyramid, not the hypotenuse, which is 17. And we'll go ahead and just solve this out. So this will be 8 squared plus 225 is equal to, I believe this was 289. And then we need to subtract 225 from both sides. So far that gives us 8 squared equals, see, 289 minus 225. $64. So 8 squared is equal to 64. Of course, then we will take the square root of both sides. So that gives us that h is equal to 8. Okay, so we found the height. So now we can go ahead and complete the volume. So we need the area of the base times the height. So we now found that the height was 8. So we can put that in. Now we still need the area of the base. Now the base of the pyramid is this triangle that's here on the bottom. So here's the base. So we need to find the area of this triangle. Now notice how this 15, see the two lines coming out? That's indicating that both sides of this triangle are the same. So this base is an isosceles triangle. Now I think it will be helpful if we redraw the triangle as though we're looking at it straight on instead of from the side. So I'm going to redraw this base over here to work on it. Okay, so I hope you can visualize this. I've taken the base, this triangle right here, and I've redrawn it over here. Okay, so this is this triangle now. And again, it's isosceles, so we know that these sides are 15. So we have 15 and 15. And we know that the base is 8. Okay, so we know that this is 8. So we need to find the area of this. So we're dealing with a triangle. So the area of a triangle is given by 1/2 the base times the height. So let's work on that. So this base is a triangle. So that's 1/2 the base of the triangle times the height of the triangle. Now we know that the base of the triangle is 8. So this is going to be 1/2 times 8. But we need the height. Alright, so this would be the height straight down. So we're going to need to do the Pythagorean theorem again. But as we go to do the Pythagorean theorem, please understand that since the whole base is 8, then this part right here will be 4. So here we have our right angle happening. I don't like the way that looks, but you get it. It's a right angle. So we have 4 and 15 is the hypotenuse. So let's do the Pythagorean theorem again. Okay, so if we do a little Pythagorean theorem for this triangle, then that's going to be, and I'll just call this x. So that's going to be x squared plus 4 squared is equal to 15 squared. Why did I put 115? I don't know. That's a mystery to both of us. So 15 squared. So that's going to be x squared plus 16 is equal to 225. Subtract the 16 from both sides, and that'll give us x squared is equal to, what is that? 209. And then we need to take the square root of both sides. Alright, so square root of 209. Alright, it's going to be some crazy decimal. So let me decide what I want to do. Alright, so let's remember what we are working on here. Our overall goal is to find the volume of this pyramid. Alright, but to find the volume, we needed to do 1/3 area of the base times the height. So we did the Pythagorean theorem, and we found the height of the pyramid was 8. But we still needed the area of the base. Now this triangle represents the base of the pyramid, so we need to find the area of it. So then we decided that the area of a triangle is 1/2 base times height. So we had to do the Pythagorean theorem again to find the height, which turned out to be the square root of 209. Now I don't like to have decimals around until the end, so I'm going to just leave it as the square root of 209. I'm running out of paper. Okay, now if I type all this in my calculator, I'm going to get a decimal, and I don't want that yet. So instead, 1/2 of 8 obviously is 4, so that means the area of the base is 4 times the square root of 209. Okay, so that's the area of the base we were looking for. So we can take that and put it where it goes, 4 times the square root of 209. Alright, if I can avoid it, I never like to have rounded decimals until the very end. So far we have an exact answer still. But now I will go ahead and just put this entire thing in my calculator and get the final answer. So I may have to look back and forth a bit. Alright, so here it is in the calculator, and wow, it went ahead and did the exact for us. So if I needed an exact answer, there it is. But I'm going to go ahead and toggle it. So 154.21, got to round up. Alright, and we had meters, so volume will be cubic meters. Alright, so that was pretty complicated. Alright, this video is getting long enough, so I'm going to go ahead and stop this video here. But there's more to come, so we're going to pick up with number 7 and get into some more difficult problems where we're looking for things other than volume. In fact, maybe I'll give you the volume and we'll work backwards to find some lengths and areas. So, I'll see you on the next video.